Now see the next part, that is part 6 of coordination compound. Of coordination compound. So many complex or coordination compound is given. So I will write first out of Ti F6 2 minus, COF6 3 minus, Cu 2 Cl2 and NiCl4 2 minus. Right, these are the compounds given to you. So every compound's atomic number is given. So for titanium it is 22, for cobalt it is 27 given, copper it is 29, and for the nickel it is 28. So it is asking about colorless species. So you have to tell me the colorless compounds, right, which will be forming. So now see the explanation for this one. So I will first explain about TiF 6 2 minus. So Ti is present in +4 oxidation state, titanium. So its electronic configuration will be, for titanium, electronic configuration will be argon 4s0 3d2, 4s2 3d2. After losing 4 electrons, when it converted into Ti4 plus, so it will be argon 4s0 3d0. All 4 electrons from the outer orbital is lost, right? So hence TiF6 is colorless. So it will become colorless. So it will be colorless. Although there is no color, it is colorless. Understood? So now see the next explanation for Cu2Cl2. So copper is present as Cu plus, and as we know, copper oxidation is 29, right? So for copper it is atomic number is 29. It is argon 4s0 3d9. It is 2 now. So after losing 1 electron, then it will become, no, this will be arranged like this, argon 4s0 3d10, right? So after losing 2 electrons, it will become 29 is there now, so it is 4s2. So 1 electron will be here, right? One electron is shifted in the d orbital for the pairing or for the stabilization, right? Now see, when it is Cu plus, so atomic number is 20 reduced, so its electronic configuration will be 4s, argon 4s 0 3d 10. So in d orbital all electrons are paired, right? So it is also paired electrons. So due to paired electron no visible light is there, no visible light. Please write it down. Now see the next question, that is 19. Which of the following complex ion is expected to absorb visible light? So compounds are given. Zinc compound, so atomic number is 30. Scandium 21 atomic number. Titanium atomic number is 22. And there is chromium, that is 24. Right. So it is asked in 2009. Absorb visible light. So those who are unpaired electrons, that will absorb the electrons. So see, I will explain third options, like chromium NH3 6 raised to 3 plus, right? So chromium is present as Cr3 plus, right? So chromium, so atomic configuration will be, electronic configuration will be argon 4s 4s2 3d4, right? So after losing 3 electrons, how many electrons will be remaining? for chromium 3 plus, because oxidation state of chromium is +3. It is assigned, right, in the complex compound. So its electronic configuration will be argon 4s0 3d3, right? So now see. So how many electrons are there in the d orbital? 3. So in d orbitals, total 3 unpaired electrons are there. 1, 2, 3. And it will do the bonding, right? So it will use the last d orbital. So it is 3dxy square y square 3d z square. Next is 4s. Next is 4px. Right. So total six ligands are there. So one will be coming here on 3dx square y square. Second will be in the 3d z square. This will be in the third, fourth, fifth, sixth. Right. So electronic. So hybridization will be what? It is 3d sp3. So this will be the hybridization. Right. So how many unpaired electrons are there for the chromium? 3 unpaired electrons. Right. So n equal to 3. 3 unpaired electrons are there, right? So due to unpaired electron, it absorbs light of visible. So write the explanation also. Due to unpaired electron, it absorbs light of visible range, yeah, region. Now see the question number 20. So in which of the following coordination entities the magnitude of delta note of CFE, octahedral field will be maximum? So it is talking about mainly cobalt. It is given atomic number is 27, right? So which of the coordination entities maximum magnitude of delta note in octahedral field will be? So see, in all the given options, central metal atom is same, right? Cobalt we are using here. So I will show the next this one. So first option is, it is COH2O 6 times raised to 3 plus. B option is, it is CONH 3 6 raised to 3 plus. C option is, it is COCN 6 raised to 3 minus. And for the D, it is COC2O4 3 raised to 3 minus. Right? It is asked in 2008. So in all the given option, central atom is same, contains same number of d orbitals. So CFE is decided by the ligands, right? So CFS is decided by ligands. So it depends on the strong field ligands and weak field ligands. Next one is, this is your first, next one will be weak field ligand, weak field ligands. Understood? So in case of CF is maximum, CN is a strong field ligands, right? So you can see here, CN is a strong field ligands. CN is strong field ligands, SFL. So it is COCN6 3 minus. So maximum CFAC is there, right? Due to the strong field ligands, maximum CFSE is there. Understood? So please write it down. All our ligands are weak field ligands. These water, ammonia and C2O4 minus. It is also weak field ligands. So all are weak field ligand. So here CN is strong field ligands. So please write it down. Next is 21 question number. Which of the following complex exhibits the highest paramagnetic behavior? So it is talking about highest paramagnetic behavior. Right. So here short term is used when it is GLY, then it is called as glycine. Glycine. When EN is there, then it is ethylene diamine. Ethylene diamine. Next is BPY. It is called bipyramidyl moieties. Right. So here central metal used is titanium. Atomic number 20, vanadium 23, iron that is 26, cobalt 27. So you have to talking about highest paramagnetic behavior. So I will give you the first point like, so paramagnetic behavior is equal to number of unpaired electrons. Paramagnetic behavior is directly proportional to number of unpaired electrons. Right. So see, so first option is vanadium. It is connected with GLY 2 times. Next is OH 2 NH3 2 raised to plus. So vanadium. So C for the vanadium, atomic number is 23, electronic configuration will be argon, 4s2 3d3. So I will do the first now. Vanadium plus charge is there. 4 plus, it is atomic number is 22, it is argon, 4s 4s 4s1, so it will become 1, right? And it will be 3d3. One electron is loosed. So that is for Va plus, right? But in this complex compound, Gy2 is there, OH2 is there, NH3 is there. So I will find the oxidation state for vanadium. So see in the next slide. So VGLY2 OH2 NH3 2 raised to plus unpaired electrons. So here vanadium is in plus 5 oxidation state. So total vanadium is 23. So electronic configuration we know, right? So it is 4s2 3d3. So these 5 electrons will be lost in vanadium plus 5 oxidation state. So reduce the minus 5 electrons. So it will be 3, 5, 4, 5. So 18 electrons will be in the vanadium V5. Right. So no unpaired electrons are there. So all electrons are lost, right? So only argon, atomic number 18, it is existing. So it is 4s0, 3d0 in vanadium plus 5. So here no unpaired electrons are there. No unpaired electrons are there. Right. Now see the explanation for the second one. It is FeEn Py NH3 2 plus. Right. So for Fe 2 plus, iron having plus 2 oxidation state here. So electronic configuration will be argon 3d6. 4 unpaired electrons are there. 4 unpaired electrons are there, right? So due to presence of strong field ligands like ammonia, strong field ligands are strong field ligands. So I will write the name for strong field ligands. It will be NH3. Next is BPY and En. So these are the short forms of the strong field ligands. So thus in Fe2 plus contain no unpaired electrons, right? Fe2 plus, so it is losing the electrons, right? No unpaired electrons. Now see in the next slide, when compound is CO, OX2, OH2 raised to minus. So for here oxidation state of cobalt is +5, right? So it will be argon 3d4. So 4 unpaired electrons are there, 4 unpaired electrons. So here these OX and OH is weak field ligands. Weak field ligands. Now see the next compound, that is titanium. It is connected with the ligands NH3 6 times raised to 3 plus. So titanium 3 plus will be, it is argon 3d1. 1 unpaired electrons are there. 1 unpaired electrons are there, right? So maximum unpaired electrons are 4, right, in this compound. So it will show the maximum paramagnetic behavior, right? So maximum 4 unpaired electrons are there is equal to maximum paramagnetic behavior. Please write it down fast. Now see the next question number 22. So d electron configuration of Cr2 plus और क्या दिया है? Next is manganese plus 2 plus Fe 2 plus nickel 2 plus. So its electronic configuration for the last orbital is given, that is 3d4. For manganese it is 3d5. For iron 2 plus is 3d6. Next is 3d8 respectively. Which one of the following aqua complex will exhibit the minimum paramagnetic behavior, right? Which of the following aqua complex? So it is reacting with the water, right? So for normal chromium atomic number is 24, and for manganese it is 25, and for iron is 20, nickel for 28, right? So 2 electrons are loose, so it will be 4s0 here iron now. So it will be 4s0, it will be 4s0, it will be 4s0. Understood? So as the number of unpaired electron increases, magnetic behavior, hence paramagnetic behavior also increases. So for 3D, for this one, Cr2 plus, 4 electrons are unpaired, 4 unpaired electrons. So in manganese, last how many 5 electrons are there? So 5 unpaired electrons. In iron it is 6 unpaired, and in nickel it is 2 unpaired electrons. right? So, iron show the maximum paramagnetic behavior and iron show the maximum, right? 6 unpaired electrons, and nickel will show the minimum paramagnetic behavior. So please write it down, this one.